Hello there, my name is Cameron, and today I'm going to teach a lesson on derivatives for grade 12 calculus. Now before I get my lesson started, I want to tell you what I'm going to go over, or how the outline of this lesson is going to go. First, we're going to start with what is a derivative. Second, we're going to go over important terms that relate to this lesson. Third, we're going to talk about the 4 types of derivatives we're going to go over. And then we're going to go over, for each of those derivatives, we're going to go over their formula and example problems, ordering in the steps of an easy problem, a medium problem, and a hard problem. And that's what our outline is going to be today. So now, let's start off with our first part with what the heck is a derivative? Well, the derivative is a function, a rule, that assigns to each value of x the slope of the tangent line at the point x, f of x. On the graph of f of x, it is the rate of change of f of x at that point. So in plain English, what the derivative is that it's pretty much the slope of a tangent line and its instantaneous rate of change. If you don't know these definitions, I'm going to get right to that. Now, moving on. Now the next term we're going to go over is instantaneous rate of change. It's instantaneous rate of change. Now, the definition, the official definition for instantaneous rate of change is pretty much, let me explain, it's like a certain point that happens at that moment. So it is the rate of change at a particular moment, same as the value of the derivative at a particular point. For a function, the instantaneous rate of change, you can also use the abbreviations ROC, at a point is the same as the slope of the tangent line. That is, it's the slope of a curve. Next we're going to go over is the slope of a tangent line. Now the slope of a tangent line, it's a line that touches a curve at a point without crossing over. More particularly, the tangent curve, which is what the derivative helps you find. Yeah. Now, next, we're going to go and talk about the power rule. Well, actually, before I get to the power rule, I should explain to you there's 4 types of rules. There's your power rule. You get your power rule. And then you got your product rule. And there you go. And then you got your quotient rule. And last but not least, your chain rule. Now these are the 4 rules that we're going to go over today. So now we're going to talk about the power rule. Now before I get into the power rule, I would like to discuss, well, its definition. The definition of the power rule is that it's one of the several rules used to find the derivative of a function. It can be used to find the derivative of a polynomial function. And now it'll make more sense when I show you what we're going to do. So now the formula of the power rule is actually pretty simple and not that hard. So we'll start off with its formula, or like its base equation. So let's just write formula. Now before I get to formula, just a basic thing you guys should know is this. What I have laid out here. D over dx is, and then you see a function beside it, is one way of saying find the derivative of this rule, what the derivative of this rule is. So they take the d divided by dx, which stands for derivative, and x minus 1, which is the normal function, not the derived function, the normal one. And then what you would do is that, get another, what you would do and write down is, let's say for x minus 1, you do d over dx, the normal function, and then the derivative function, which would be 1. Now, this is going to come into play of the power rule. So x minus 1, how did I get 1? So this involves the formula. The formula of the power rule, let's see, it's d over dx, x to the power of n. X power of n is the normal function, which would equal to nx n minus 1. That's your derivative of this. That's what the power rule does. So let me just go ahead and start with an example. Let's start off with an easy example, okay? So let's say you're given the function y equals x squared, or no, let's make that x cubed. Scratch that out. Y equals x cubed. Now, following this, n is the exponent. N, right here, is the exponent. And you want to bring down n, and then minus what you have here. So, y prime. This is the same. This, just by the way, is also equal to saying this. They both mean derivative. So how you would write this function is y prime. And so you want to find, okay, see? So bring the 3 down in front of the x, and then you minus it by 1. Minus 1. Now let's go ahead and just do that. So bring the 3 down, and you put the x, and then 3 minus 1. Just do another line. 3x minus 1. Now you get, which is 2. 3x cubed. There you go. That's your derivative. Now let's move on to something more complicated. Let's go start off with a medium question. Medium level question. Now, a medium level question would be something a bit harder. Let's go with y equals 3x to the power of 7. Now, what's the derivative? Ooh, looks a bit tricky, right? There's already a coefficient. What do you do? Well, it's actually pretty simple. Take y prime, or y. And now, what you still do is you take this and you still bring it down. But whatever the exponent here, and if there's already a coefficient here, you just times it. So 7 times 3 is equal to 21. So there you go. And the reason it didn't look like that before, so it's the same thing for even this one. You take the 3, you bring it down, and pretend there's an imaginary 1 in front of the x, because of 1x, right? So technically you're taking 3 and you're timesing it by 1, and you still get 3. Same thing, it works for this too. You bring it down, now you got 7 times 3, x, 7 minus 1, 7 minus 1. Now you get 21, x, 7 minus 1, 6. There's your derivative. Now let's move on to something a bit harder. Let's do that. Let's go something harder. Now, so you're given the function 4x 2 or 5. Now, for some reason, people tend to freak out when they see in a fraction, especially an exponent. But it's actually pretty simple. The same rule applies. Remember your equation? It is d over dx xn is equal to nx n minus 1. Same thing. So what you do is that you take the 4. Well, you leave the 4 actually. You take the 2 over 5. You bring it over. And you times it by the 4. I'll just go ahead and do that. 2 over 5 times the 4 x. Then you take 2 over 5 number, n minus 1, minus it by 1. Now 2 over 5, since it's a fraction, you just multiply the top. So you would get 8 over 5, 2 over 5 minus 1. It's negative 3 over 5. Now that's it. If you like, or if your teacher wants you to, you can even go further and simplify this more. Usually it's not proper form to leave a negative exponent, so you bring negative. That means it's 1 over x, whatever the exponent is, make it positive. 1 times 5, you get 3 over 5 right here. There you go. So that can be another form of derivative. Now, well, there's your power rule. There's the 3 problems you typically see, and that's it for power rule. Okay, so now we just did the power rule. Okay, now we got 3 more to go. The second one will be the product rule. Now the product rule, the official definition of the product rule is this is one of the several rules used to find the derivative of a function. Specifically, is used to find the derivative of a product of 2 functions. The product rule also has another name of it. I don't know if you guys heard of it, but it's also known as Leibniz law. Just write that down for you. Leibniz law. I don't know if you guys heard of it, but that's another way of calling the product rule. Because the man, I guess like a scientist named Leibniz, tongue twister another name, probably came up with this rule. Anyways, moving on. Now, the formula of this rule. Now, when we say it's the derivative to find of 2 functions, you'd write right here. Now, let's say you want to find the derivative of f of x times g of x. That's your original function. Let's just say f of x is a polynomial expression, or polynomial function, and g of x another polynomial. Now you want to find the derivative of these two. Now the derivative equation is this how it would go. Fine, let's just do the equal sign down here. This would be derivative of f of x. So the derivative of the first polynomial times the original of the original second polynomial plus the original first polynomial times the derivative of the second polynomial. That's what it'd be. Now let's go straight to an example so we can put this rule into play. Start off with something easy. Let's see why it can be something easy. I got something. Let's do y equals x squared. Let me just write this bigger for you guys. Y equals x squared times 3x4. Can be anything, and it just has to be 2 functions, honestly. 2 different functions. Doesn't even have to be a polynomial. Well, y prime, we discussed this earlier. Now c, you're gonna find, make this easier. Let's use a different pen here. Think of this as f of x, and think of this as g of x. Now, remember you have First one is the derivative of f of x. Let's do that. The derivative, see, we used the power rule. Power rule, remember, bring it down to 2. Minus it by 1, so 2 minus 1 is 2, so 2x1 times the original of g of x, so right here. Now you plus it by the original of f of x, because remember, right here, so x squared, times the derivative of g of x. Remember, bring the exponent down, then you times the exponent by the coefficient, so 3 times 4 is 12. And then 4 minus 1 is 3. So, and voila. There you go. You got your derivative, your product rule derivative of this function. Now you can go ahead and simplify that. 6x to the power 5 plus 12x to the power 5 should get you 18x to the power 5. There you go. There's your derivative. Move on to something a bit harder. Okay, let's go with something. Let's go with y equals x squared plus 4 cubed plus 7x squared. Okay. Oh no, what's this? It's just a number. There's no formula. What would you do here? Well, it's actually pretty simple. Whenever you see just a number without any x or any type of sort of variable at all, doesn't matter if the number is squared. When the derivative of a numeral, it's always 0. It's always going to be 0. That's how it. Okay, so you got a medium. It's just how it is. Whenever 4 is, the derivative is always going to be 0. So let's do this. Now write down. Remember d over dx of, now x squared, remember this is your first function, so think of it as f of x. Think of this one g of x. Okay, now let's solve this equation. Y prime, now same thing, power rule, bring the 2 down, x. Then you got power of 1, don't have to write that. Now 0, because the number is always 0. Now go to the next one. 3x cubed plus 7x squared. Plus, now the normal function of this, as you can see, normal. Times, now, remember, bring the 3 down. 3 times 3 is 9, and then 3 minus 1 is 2. So 9x squared, you do the same thing here. Bring the 2 down. 2 times 7 is 14. 2 minus 1 is power of 1. There you go. And now you can even go ahead and simplify this, but it just depends what you teach us, but you don't have to do that. I can do it for this one. Let's move on to something hard. Let's give it another paper. I'm just gonna put it like this, just for easier sake. Now let's do the function. There's your first function. Second function, or polynomial. There you go. There's your original function. Now you would have to find the derivative. So before I actually find the derivative, I'm gonna let you guys try to solve this one. Just pause the video and take a guess at this. All right. So moving on. Hopefully you guys tried solving this, but let's see if you got it right. So now, again, you bring the 2 down. So 2 times 3 to the power 3 over 7 x squared. 2 minus 1 is 1. My bad. Plus 4, because remember, x power of 1 minus 0 is 0. X power of 0 is 1. So just 4. And see a numeral, so just 0. Or just again, think of this as f of x and g of x. Let's see f of x and g of x. Now move on to the next one. You keep the normal function for x3 plus 74 over 7 x squared plus 14x plus 4. Now you would wanna plus seems to be running out of space. So you got 2x. See, now you gotta do the second part of the equation. So normal f of x and then derivative of the g of x. So you got 3 over 7 x squared plus 4x plus 7 times the derivative of that, which would be, what would that be? 3 times 64x squared, because 3 minus 1. 74, so 2 times 74 over 7. 2 minus 1 is 1, so just leave it as x. And then x power of 0 is just 14. And then remember, it's a numeral, so just make it 0. There you go. Now you want to simplify this, or actually multiply it all up. So we'll start from this side, right here. Now you 2 times 3 to the power 7, the denominator, so it'll be 6 over 7 x to the power 1, so you don't need just x, plus 4. There's your first part. Second one, just keep it the same. 64 x power 3 plus 74 over 7 x squared plus 14x plus 4. Now you plus it, keep the original, since it's original f of x on this side, 4x plus 7. And then 3 times 64, 3 times 64 I believe is 192. X squared plus 74 times 2 is 148. Divided by 7, don't forget about that. X plus 14. And there you go. There's your advanced card equation, or not equation, my bad. Derivative. This is your derivative of this function right here. There you go. Now you know product rule and how to solve the hard ones. Alright, so far we did 2 derivatives. Now we have 2 more. This derivative is, or the rule we're going to learn, is quotient rule. And the quotient rule is pretty much straightforward and very, very similar to the product rule. So pretty much the quotient rule is one of the main rules used to find derivatives, and it only works with fractions. Meaning that there's your formula. As you can see, you got the derivative of f of x divided by g of x. And then, oh, see this? See the top function right here? Very, very, very similar to the product rule. Let's get the product rule out. Right there. There's your product rule. And there's your quotient rule. So the product rule is pretty much, okay. So the quotient rule, the only difference between the quotient rule and product rule is that the quotient rule, instead of plussing at the center, you minus it. And you divide the whole, well, you divide the top by g of x squared. The original, not the derivative. So pretty much quotient rule is derivative of f of x times normal g of x minus f of x times the derivative of g of x. Divide the whole thing by g of x squared. That's it. Alright, now let's go do some problems. Alright, so right here we got y equals x to the power of 4 divided by 3x to the power of 9. And let's go right ahead and bring that up a bit. Don't need that. Let's go right ahead and solve this. Got prime y. So again, want to use your function. So x4 is first derivative. So bring the 4 down. 4 minus 1 is 3. Times the normal function, 3x9. Minus normal function x4, again product rule, except bring the 9 down, times it by 3, 27, x 8 minus 9 minus 1, sorry, 8. And divide the whole thing by g of x squared, since it's g of x. So this therefore would be 3x9 squared. Now that's pretty much it. There's your quotient rule. Now you can go ahead and simplify that. 4 times 3 is 12. 12, 3 plus 9 is x to the power of 12. Coincidence. Now x to the power of 4 and 8, so that's 12, so 27 to x to the power of 12 again. Divide the whole thing, 9. 3x to the power of 9 times 2, because it's outside the bracket, 18. Now let's see what you get. 12 minus 27, I believe that is, well, it's obviously a negative, so it would be negative 15. X to the power of 12. And what do you know? They actually cancel out. Look, see? 3 divided by 15 is, let's write this first. 3 divided by negative 15 is negative 5. And then you got 12 minus 8, which would be, well, actually you don't want to mess with that, but let's just keep it at x. Yeah, it's x to the power of 12, then x to the power of 18. Now you could simplify more, but I'm just going to leave it at that so it doesn't confuse you. Alright, now let's go to something a bit harder. Medium. Now, I'm going to go write down our quotient rule. There's your quotient rule, just a reminder. Now, okay, this isn't, it may look complicated because it's just bigger numbers, wider, but no, you should be fine. So all you gotta do is just follow the steps. X squared plus 5, that's your first function, so you want to find the derivative of that. So what you would do is, it would be 2x, 2 minus 1 is 1, number is a numeral, so it's a 0. Put the normal function, plus x plus 92, and then you minus it, which is now the x squared plus 5, plus the derivative of this function, which would be 3 times 2 is 6, 6, 2 minus 1, plus 1, because x to the power of 1 is 1, and then it's a numeral 0. Then times it by 3x squared plus x plus 92 squared. There you go. That's your derivative for the medium. I could simplify it, but I'm not. Now we got a hard. Now this is gonna be. It's bigger, but again, same concept. So first you want to do the derivative of f of x. Let's write that down. F of x, g of x. Let's go 14x plus 41, because power rule, times the original function 101x cubed plus 72x. 101 times 3 x squared plus 72 times 2x plus 41. Now, this whole thing by 101x cubed plus 72x squared plus 41x plus 4 squared. Okay, let's just keep that. It's a bit complicated. There we go. Now let's go to the next line. Should be 14x plus 41. Keep the same. 101 x 372 squared plus 41x plus 4 minus 7x squared plus 41x plus 7 plus 303, because 101 times 3 is 303, x squared plus 72 times 2, which is 144, x plus 41. And then you want to divide the whole thing. Whoops. Cut. Okay, play. You're going to divide the whole thing by same thing. There you go. That's how you divide it out for, well, that's the question rule for this one. And now just have one more left, just the chain rule. Okay, so far we did 3 rules. We did power rule, product rule, and quotient rule. I have one left, which is known as the chain rule. Now, the chain rule is a rule for differentiating compositions of functions. When I say composition, I mean a mix of functions, not a work of art. Anyways, moving on. Now we go to the formula of this function. The formula of this function is the derivative of the outer function times the derivative of the inner function. As you can see, f of g of x. So what it means is that the derivative of the outer function times the derivative of the inner function. Now, let's move on to an example so it makes more sense and you're not as confused. Now let's do something easy. Okay. Alright, so right now you guys, I have x minus 1 to the power of 2. Now you would think, oh, just times it by 2 and do a product rule. Well, you could do that, but the more proper format of it would be, or more secure format of it, would be using this rule, which is the, let's watch the chain rule play. Now if you can't see the formula on the side properly, there is right there. Alright, so center all this right here. Now you got x1. Now remember, think of x minus 1. Here, let's use a pen. think of x minus 1. Let's just for saying, let's equal that c. Now you got y equals c squared. Doesn't this look familiar? It looks something like x squared. Same thing, right? Right there, that's a parallel. You can use that as a parallel. Now you take y. Well, this is a derivative. Oh no, it's not a derivative. Y equals x. So you bring the 2 down. 2x, 2 minus 1, 2x to the power 1, which is equal to 2x. Now just plug x minus 1 back in. So now you got 2x minus 1. There you go. Now you did the derivative of the outer function. Now all you gotta do is the derivative of the inner function. So you times it. So you do 2x minus 1. Now you do 2x minus 1 times the derivative of the inner function. So x minus 1. Ignore that 2 completely. Just do x minus 1. Now x minus 1 is easy. There we all know x minus 1 is 1 because bring it down. So yeah, 1. Now in the end this would equal 2x minus 1 because anything times by 1 it's the same. Now let's go on to something a bit harder. Okay, now right here you got a medium 1. Now you got, now the outer function is 3 and the exponent 5. And we'll do the same rule. And the inner is, this looks very familiar, it's a product rule. So now you already know what to do. Now let's make the inner function, all this right here, equal b. So now you got 3b to the power of 5. Similar to something like 3x to the power of 5. Power rule again. So you go y to the power of 3 times 5 because you bring the 5 down. B 5 minus 1, which equals to 15b to the power of 4. Now you open up that b right there and you turn it back into its normal equation. So now you would have 15b. Remember, keep the inside the same. You don't touch the inside when you're doing the outer derivative. The derivative of the outer function, sorry. So 3x4 plus 7x. Just make that more clear. That's an inner function. 4. Now you times it by the inner function. Now the inner function is a product rule, and we all know. It's done a different color. Now the product would be, let's see, number. You all remember our right here. You all remember our product rule, right? There you go. There's our product rule. See, f of x times g of x. Let me just think of that as f of x, and you can think of that as g of x times it by 2x times 3x4 plus 7x plus, do that, plus, what is this, x squared times 3 times 4 because you bring the exponent down. It's 12x because 4 minus 1 is 3 plus 7 because x power of 0 is 1. And there you go. There's your chain rule. You can go ahead and simplify that if you like, but let's keep like that. Alright. Now next one. Okay. This looks a bit tricky right here. Now it's again the same concept, except might be a bit of a. Now we'll start. You can see here you gotta kind of do like a double chain rule, because first you got just that. If you ignore all this right here, well, you got 74 and 3 is the most outer, and then you do the inner times the inner, right? And the inner is 4 times 2, and then the derivative of the inner is a chain rule. So here I'll show you step at a time to make more sense. Now let's make this whole thing right here. Let's make that W. So we got 74. Let's equal Oops, 70w, nope. 74w to the power of 3. Okay? Now, let's do the derivative. Now I bring the 3 down. 74 times 3. 74 times 3 would be, I believe, let's just do this. 74 times 3. W2, because 2 minus 1. And that would also equal to, let's see, 74 times 3. I believe that'd be 2219. Let's just double check just in case. Oh, 222, my bad. 222. So you get 222. I think that's a 71. W squared. Now, so you got 2w that. Now you gotta do the more inner function. So now you got another chain rule. So ignore the outer function. Now you're moving to the inner. So you got 2, 2, 2, w2. That's the most outer function. Now you gotta do the derivative of the inner function. Inner function is this right here, which is just circled in pink and red. Now derivative of that is another chain rule. Now you know the derivative of chain rule is the outer times the inner. So you do, now all you do is ignore this and you ignore inside. Now all you have to worry about is the 4 and the 2. Now in the 4 and the 2, let's make that equal z. So 4z squared. Now you times it, because times the inner derivative. Now 4z squared. Now you bring the 4 down. So do it. My bad. Okay, ignore that. Now 4 times 2. So which is 8. Sorry about that, guys. So now you got 4 times 2, which is 8. Oh my god. Okay, today I'm messing up. Okay. This all. Start this. Okay, so now you got 222w squared. There you go. That's the derivative of the most outer function. 2 squared. And now I just open up that w. That w will be this whole function here, right? So that would also be equal to 2. It's going to be a big number. 4 times x squared plus 7 divided by 41 x cubed plus 7x squared plus 5. Boom. And then squared. And then what is it? Squared right here again. Now you gotta do the derivative of the more inner function, which would be this right here. So you ignore the outer function, ignore the complete inner function. Now you just got 4 and 2. That's your outer function. Because the reason we're doing this is because the chain rule is derivative of the outer function times the derivative of the inner function. So now let's think step 1. You got the outer function done. Now you go to the inner function. The inner function is this. Now if you zoom into this function only, this is a chain rule. So now you got to do the derivative of a chain rule, which is the outer function times the derivative of the inner function. Get what I'm saying? Okay. So now you do the outer function. So 4 and 2. Again, same thing, power rule. You could take 4 and 2 and put the inner function of 4 to the power of 2, sorry, as z. Now take 4 to the power of z, or 4z squared. Let's see, the derivative of that would be, let's put it right here, 4z squared. The derivative of that, so d over dx 4z squared, that would equal power rule, so 8z. There you go. Now you take 8z, and z is equal to this whole inner function. You take that and times it by this. Now you take z and substitute it back in the original derivative, the inner function. So it'll be 8 times x squared plus 7 divided by 41x cubed plus 7x squared plus 5. And now you ignore all of this and do the derivative of the inner function. The inner function is right there. It's a quotient rule. Now the quotient rule, let's expand this out right here, like that. Now you got a quotient rule going for you. You all remember the quotient rule. Remember, it's x squared, so remember its quotient rule is, let's write that down for you. There's your quotient rule. And now, so f of x at the top, g of x at the bottom. So you times by the inner, so 2x. Remember, it's a 7, so 7's a numeral. Times the normal function, so 41x 3 plus 7x squared plus 5 minus the normal function at the top, f of x function, x squared plus 7. Now you find the derivative of the bottom function, which is 41 times 3. 41 times 3 is 123, I believe. Hopefully I'm right. Let's just double check that. 41 times 3. Yes, I was right. 123. X 3 minus 1, or 2. Plus 7x. 7 times 2 is 14. 14x, because 2 minus 1. I mean, don't count the numerals. And then you'd all divide it by 41x cubed plus 7x squared plus 5. Square the whole thing. And there you go. Let me just write this derivative out one more time at the bottom, if it's all proper and normal. Now this whole derivative should be I'm just gonna times the coefficients together, so it looks more, so it's not as messy. Actually, no, I'll leave it so you guys understand. Terrible 8. And there you have it, your chain rule. And that's the chain rule of this hard function right here. Okay. Now you guys have learned the product rule, how to do the product rule, the power rule, the quotient rule, and the chain rule. Thank you. Have a good day.